Yes, from today onwards and in our upcoming few sessions, we are going to keep discuss on security part. So what are the things we are going to cover? First of all, we are going to discuss password hashing. So what is password hashing? How to implement password hashing? That is what we are going to discuss in today's session. We are also going to discuss encryption and decryption. So how to implement encryption and decryption in ASP.NET Core Web API. I mean, how you can send the data in encrypted format, how the server decrypt the data, how the server send the response in encrypted format, how the client is going to decrypt the data. That is what we are going to discuss. Next, what we are going to discuss something called HMAC, hash-based message authentication code. So it is one of the important security measure to verify or to ensure that the request is coming from a trusted client. The request is not being tampered by someone from the middle, that is man of the middle attack. So to ensure the request is a valid request, the request is coming from a valid client, the request is not being tampered by someone else, we need to use something called HMAC authentication. After HMAC authentication, what we are going to discuss? We are going to discuss basic authentication. So what is basic authentication? How to implement basic authentication? Right? How you are going to create the basic authentication? I mean the username and password. How you are going to create the base and 64 encoded string? How you can pass? That is what we are going to discuss. After basic authentication, we are going to discuss how to implement a role-based basic authentication in our ASP.NET Core Web API project. So basic authentication, simply validating the authentication part. So role-based authentication means authentication plus authorization, whether the user having a proper role to access a particular resource. So that what we are going to implement using role-based basic authentication. So after role-based basic authentication, what next we are going to discuss? We are going to discuss something called JWT authentication. So we'll discuss what is JWT authentication, what are the signature, what are the three key components of JWT authentications, how to implement JWT authentication in our ASP.NET Web API project. That is what we are going to discuss. Not all guys, remember, whenever I'm discussing this thing, don't think that I'm only going to discuss the Web API part, but also I'm going to discuss how the client can consume these services. For example, if I'm showing some encryption and decryption in my web API application, then I also need to tell you how the client is going to generate the encryption logic, generate the decryption logic, how the client is going to consume the services with encryption, decryption, with HMAC, with the basic authentication. So it's a point that you need to remember. So whatever we are discussing here, at this point of time, right, not only we are going to develop the server application, that is ASP.NET Core Web API, but also we are going to discuss our client application. Without client application, how we can do the testing? That is impossible. So that's what we are also going to discuss. So once the JWT authentication is discussed, then we will discuss something called the JWT, role-based JWT authentication. After JWT, role-based JWT authentication, we are going to discuss something called refresh token. We are going to discuss something called client validation. So all these things are related to JWT authentication, right? So once we have discussed the JWT, then we are going to discuss something called cost. So basically, it is one of the security standard which will prevent the browser to make a right cross-domain jQuery Ajax call, right? So how you can enable this? So that is what we are going to discuss. And finally, we will complete with the SSO authentication. So SSO authentication is also one of the important security measure nowadays used in industry. So how to implement SSO authentication? So practically, right, whatever I'm showing here, every concept I'm going to show you with practical. I mean, by giving some real-time scenarios, I'm going to explain all these things. So these are the things what we are going to discuss in our few upcoming sessions, including today. Is that clear?
Yes.
Yes, sir.
Right. So today I'm targeting these two things, right? So what is password hashing, how to implement, why it is important to implement password hashing, as well as I'm going to discuss encryption and decryption, how you implement in ASP.NET Core Web API, And also I'm going to discuss how to generate a client application, consume the services using encryption and decryption logic. Clear? Anyone having any question, guys? So first, the first point or the first security feature what we are going to discuss is password hashing. So what is password hashing? Guys, remember why we are using a database. We are using the database to store the data. And one of the important data is going to store in the database is the user information. So without user, the database is useless. So whenever you take any kind of a database into consideration, whether it is a banking application, whether it is a e-commerce application, whether it is a social media application, whatever type of applications you take into consideration, user table must be there. Inside the user table, we are also going to store the user information. And most of the applications, right, they are providing some kind of a login functionality. Login functionality in the sense, either you can implement right password-based authentication, you can implement OTP-based authentication, right, whatever. And one of the most common approach is password-based authentication. So password-based authentication means what? Means the user needs to provide the username as well as the password, and then you will make a request to the server. The server will verify whether the provided username and password are correct or not in the database. And if the data, if the data is valid, I mean the whatever username and password provided by the user, if that exists in the database, that means it's a valid user. So we can generate it right. In most of the time, once the credential are valid, we are generally going to create a JWT token, and that token will return to the client so that can consume the upcoming or the rest services using the token. But here, what is important? Important is how we are going to store the password in the database. Do I need to store the password in plain text? If yes, then what are the problems? See, if I'm going to store the password in plain text in the database, then what is the problem? The problem is whoever have access to the database, they can see the password. For example, you are having access to the database. Most of the time, the developer, right, as a normal developer, you might get some database access with the read-only functionality. Read-only in the sense, you cannot perform any update, insert, or delete operation. You can only execute the select query in the database. And that is more than sufficient. For example, whatever the user data, you make a query, you verify what is the username, what is the password. By taking the username and password on behalf of that user, you can log into the application. Second thing is that, for example, right, you are a very good human being and you didn't do this thing, but which is I never believed, right? Anyone can do this thing. But what about the hacker? If your database is compromised, some unauthenticated user, they got access to the database. Then what will happen? So they can access the database means they can have the username and password as the password is in plain text. So what they can do, they can give access to the database. So whatever they want to do, they can. So we need to provide restriction to this. So we should not say how we can provide the restriction. So we can provide the restriction by creating the password in a hashed format. So whatever the original password, so that what we are not going to store. Instead of that, what we are going to do, we are going to store the password in a hashed format. If we are storing the password in a hashed format, that is in some encrypted format, then what will happen? Now, if you log in, if you have access to the database, even though you have access, you cannot identify what is the original password. Forget about the hacker. They also not identify what is the original password. So in that way, we can provide security to user account. See how it is going to work. Let us try to observe. So user provides the password, input password. So what we need to do, right? Again, guys, remember this password, that encrypted password, it will come into two picture. One, at the time of a registration, we are going to store the password. Second, at the time of login, we will validate the password. See how we are going to do. So user will provide the username and password. So, sorry, not password in the case of a registration. In the case of a registration, whatever all basic information you are taking right about the user, along with this, you are also going to take the password. So once you got the password, then what we need to do, you need to generate a random salt along with a key. So basically what exactly it means? It means you need to generate a secret key, right? And that secret key you can generate by using some kind of a algorithm, that is HMAC, right? SHA256, SHA512, right? So how you are going to use this right HMAC algorithm, I'm going to discuss. But for now, just remember what you need to do. So based on the algorithm, you need to generate a secret key, and then using that secret key and whatever the password provided by the user, we need to generate the password hash. And once the password hash is generated, then what we need to do, along with the secret key, or you can say along with the salt, we are also going to store the password in the database. So basically, what exactly we are storing in the database? We are storing the encrypted password. And how that password is encrypted, I mean using what salt or key, that what we are going to store. Here, how it is going to be stored. Now if someone have a look on the database, he can see the encrypted password and the salt, but he cannot decrypt the password here. Why? Because this is only for the encryption purpose. So in this case, this password, what we are going to store in the database, it can have only one way direction. One way direction means what? Now it means it can only generate the password and store the password. If you are trying to, right, what I can say, decrypt the password using this salt, that is not possible. Only encryption is available, no decryption is available. Now you might have one question, sir, if the password is stored in the encrypted format, which can never be decrypted, then how we can validate? Because whenever the user going to write login, he is not going to provide the encrypted password. He is going to provide the plain text. Now how we can verify that plain text with this encrypted password? Now again we need to do the same thing. What we need to do? Now here the user will input the username and password. Let's assume that a username is nothing but email ID. Then based on the unique email ID, what we need to do, we need to retrieve the corresponding salt and the hashed password from the database. Once you retrieve the salt and the user provided password, then what you need to do, you need to generate the HMAC, right? Again, you need to use the same HMAC algorithm to compute the password hash. So with the user provided password and with the stored salt, you have to generate the hash, and this generated hash you need to compare with the stored hash which is already stored in the database. If the both the hash are matched, that means the password is correct and you should proceed with the request. Clear how it will be work in our application?
Yes, Pandit.
Okay. So these are the reasons: security of user data, one-way protection, data integrity, salting, right? Prevent password reuse attacks, right? So these are some of the, right, what I can say, use cases or why you should protect the password. That's what we have already discussed. Now let us see one example to understand how you can implement password hashing in ASP.NET Core Web API. You can make use of SHA256, SHA512. Anyone is fine. SHA256 means it is going to generate the data with 256 bits, 256 bits, and in this case, it is going to be 512 bits. So otherwise, right, this will give you more right security than this one, but this one is going to be faster than this one. So here it will be faster but less security because the key size is going to be 256, and here it is going to be better security, but it will take more time because the key size is more. Key size is more means the computational power is going to be better, right? It will take more time, but nowadays the powerful computer what we are using, so you will not find any performance differences between these two algorithms. So most of the time, right, in your real-time application, you need to use this SHA-52 hashing algorithm. So let us proceed and understand this step by step with one example. So let me go ahead and create one Visual Studio application.
Pranay, I have a query.
Yes, please.
Yeah, so when we are encrypting it using this SHA512, is there any other way to decrypt it as well? Like if someone
So
gets
then,
the yeah.
see what I'm saying, it is a one-way traffic. So that's what I have already told you. There is only encrypted. You can only generate the hash. You can never decrypt the hash to its original form. There is no way,
There is no way. Okay.
right? So that encryption, decryption, that is a completely different story altogether. So encryption and decryption is different. Hashing is different. Clear?
Okay.
That
Okay.
encryption, decryption we will discuss later. But for time being, right, what hashing algorithm we are going to use, that algorithm can only provide the option to generate or to compute the hash. There is no method, right, which you can use to decrypt the hash.
Okay. Okay. In the end of this lecture, Pranay, if time permits, can you just explain the difference between the hashing and the encryption or encoding?
So both options I'm going to discuss now. First example, what I'm showing, that is password hashing. Second, I'm going to discuss encryption and decryption so that you will get a better clarity.
Okay. Sure. Thank you.
Practically, see, whatever I'm going to discuss, practically I will show you. So once I show you the real-time example, right, what is the use of password hashing, then I will take another example to explain what is the importance of encryption and decryption. Both practical real-time example I'm going to show you. Clear?
Okay. Okay. Yeah. Thank you.
So now what I'm going to do is I'm going to create a write project, select a web API. Any name you can give. I'm giving password hashing demo. Click on the create button. So in this case, as I'm going to store the data in the database. So for this purpose, what I'm going to use SQL Server database. I'm going to use Entity Framework Core code first approach. So what we need to do next? Next, we need to install the necessary NuGet packages which are required for Entity Framework Core along with SQL Server database. So these are the two packages that what we need to install into our project. So let me go ahead, create a class file. Sorry, open package manager console, then click on the enter button. So this will install the package for SQL Server data provider. This package, the second package what I'm installing, this will provide the support for, right? Tell me what is the use of the second package? Migration, right? So database migration. So to sync your model classes with the database, you need migration. For that purpose, you need the second package. Next, what I'm going to do is I will create a table, right, where we need to store the data. So for this purpose, as I'm going to use Entity Framework Core code first approach, so first of all, I need to create a model class, or you can say entity, for which I need to create a database. So in this case, what should be the model class name? Whatever you need, rate you want, you can give. I'm giving the class name as user. So this class is going to define the required properties, and these properties will be created as columns in the database. So you can see I'm defining this. This key property is mandatory or optional in this case, guys. This key
Mandatory
property
also use
Mandatory.
ID. Also use
mandatory.
ID.
Right? Why mandatory? What is the default convention? If I'm not providing, is there any issue? So what exactly it is looking for? It is looking for ID. Otherwise,
ID.
whatever
Yeah.
your entity name plus ID. So ID is there by default. This is going to be primary key. So no need to specify the key attribute. But if you are specifying, that is a good programming practice, right? So what data we are going to store? ID, first name, last name. So this is for just information purpose. Email. This is going to be unique ID. So I want to mark this email as a unique. So what I'm doing here, I'm applying the index attribute and I'm specifying that each unique is equal to true. So each unique equals to true means which will create a unique index on the email ID column, which will restrict duplicate entries. And here you have to remember two things. One is password hash. All right, based on the provided password, we need to generate a password hash. And how is that password hash generated? For that purpose, we need a salt, that is password salt. So based on the password salt, that password hash is generated. But guys, remember, based on this password salt, you cannot retrieve the original password from this hash. That refers, right? Reversibility is not possible with Axiom. Now this is the data what we have stored. We want to create a table, right? For that purpose, what I need to do, we need to use a DB context class. So that is what we will discuss. But before that, what I'm going to do is I'm going to design my DTOs. So DTOs means what? data transfer object. So whatever the data we want to transfer between the, what I can say, client application and our server application, for that purpose we need a DTO. So you can create a separate folder for DTO. So for time being, I'm creating all the classes within the models folder. So registration DTO. So this registration DTO is going to contain all the data whichever required for registration. See, in the user ID, so this ID is required in the database table. But while I'm going to do the registration, do I need to take this ID value? No. This is going to be auto-generated by the database. So you can say I'm taking only the first name, last name, email, and the password. And in this case, you can see in the database, do I have any column for password? No. So we in the database, we are creating two columns. One is password hash, another one is password sort. While I'm going to take the data from the user, at the time I need to take first name, last name, email, and password. Clear?
Yes.
Is that clear?
Yes.
Okay. So now you just tell me, then what are the data we need to take in the login DTO? What are the data we need to take in the login DTO? Definitely, we need to take username, or you can say email and the password. So basically, the login DTO is going to contain two properties. What are the properties? Email and password. Clear? And if you want to mark this is not null, all right, you can apply this one. Right? And this password is also not. Even this is not required. Why? Because we have applied the required attribute. So this is going to my DTOs. Next, what I need to do, as we are going to use entity framework, we need the connection string. So for this purpose, I'm going to add a key with the name EF core DB connection, and it is pointing to the user's DB. So let me open my SSMS and see whether this DB is already exist. If it exists, then we need to delete so that it will create a fresh DB. So let me go ahead. So this is my database. So let me delete this user's DB. Let me give the name as a user's DB. So this is my database. Next, what I need to do, I need to create the DB context class. So according to the industry standard, you need to create a folder called data. Within the data folder, you can create the DB context class. But here, I'm putting everything inside the models folder to save the time. So in the DB context class, we don't need to do anything special. What I'm doing here, I'm simply creating this DB set property user. So this users means it will create a database table with the name users, which will be mapped to our user entity. So it will be mapped to this user entity. Right. Next, what I need to do, we need to register the DB context in our program.cs class file. So first of all, what I'm going to do, let me show you. So this is my program class. In the program class, I need to register this. So basically, first of all, I'm disabling the camel case naming convention. So whatever the property name we defined in the DTO, so we want to keep the same property name. For example, it should come as first name, last name, where F and N are going to be in capital case, right? So that is what the first changes I have to do. Second changes, I need to register my DB context class. So how you can do this? Now, by using the add DB context method, you can register your user DB context class. We have already discussed this many things. So here it is going to use SQL Server connection string. The connection string will come from the offsettings.json file. So these are the changes. After these changes, we need to generate the migration file. So how you can generate the migration file? First of all, make sure the program is built. So click on the build button. Okay. So build is succeeded. Next, we need to generate the migration file. So package manager console, add migration, MIG1. Okay. Then we need to update the database. So once we execute this command, this will create a new database and database. So you should see the database here now, users DB, and it should have that users table. So if you verify the users table, currently it doesn't have any data. So here ID, first name, last name, email, password, and password solved. So now Now what we need to do, we need to implement password hashing, right? So to securely hash and verify password, you can use HMAC512 or HMACSHA256. As I have already told you, this 512 give you better security over 526 over 256, but 256 will give you better performance over this one. So one giving better security, another one is giving better performance. So what is your main objective if you compromise the security and you are giving more priority to performance? Then you can go with this up 256. But if you are giving priority to security over performance, then you have to use this one, right? So let us proceed and see what we can how we can implement this password hashing in our application. So this purpose, what I'm going to do, I'm going to create a password helper class. So this helper class is going to have it is going to have two method. One method is going to create the password. Another method is going to verify the password. So let me proceed and create this class file. And within this class file, I'm going to define two methods. One method will use to generate the password hash. Another method is going to verify the password hash. So let me proceed and see how you can implement this thing. Okay, see, this is my create password method. So whatever the original password, this password is going to be in plain text. And here what I'm doing, I'm declaring two variables, right? One variable for the password hash, this is going to be byte array. Another variable is password salt, this is also going to be byte array, right? So these are going to be my two passwords. So hash means it should be in the form of a byte array, right? So now what I need to do, I need to generate the password as well as generate the I need to generate the password hash. But before generating the password hash, I need to generate the password salt. Once I generate the password salt, then I will use this password salt along with this plain text password to generate the password hash. See how we can do this. First of all, you have to create the instance of a SMAC hashing algorithm. See here HMAC SHA512 I'm using, but if you can use HMAC, so instead of a 512, you can also use a 256. That is also possible, right? So whatever algorithm you are using, but mostly as an industry standard, we are going to use this one. So once you create the algorithm, automatically one salt is going to be generated. And that salt you can access from this key property. So first of all, create an instance, then access the key property, which is going to give the password salt. So once you got the password salt, it is going to be in the byte array. So what you need to do, you have to convert that into byte array. So this is going to be byte array. Again, we need to convert that right? Once you have this, right, then what you need to do, you need to convert that byte array into UTF-8 encoding standard. So this is byte array. This is also going to be byte array, but this byte array is following the UTF-8 coding standard. So once you have the password byte array, and once you have the plain password, then you can compute. So how you can do this? Compute hash. So call the compute hash method and pass this password. Okay, see, guys, remember I have some mistake I have done. So this is going to be my password byte arrays. Password solved. So you can see this is a byte array output variable. So this variable and this variable we need to initialize. Why? Because these are out variable. So out variable means within this method, definitely we need to initialize these two. So first of all, we are getting the password solved from the key property of the HMAC algorithm. Once we have the password solved, then what we need to do? We need to generate the password byte. But here you can see the password is in the form of a plain text. So this plain text I need to convert into a byte array. So how you can do this? By using this get byte method. So by using this get byte method, we need to pass the password. So this plain text will be converted into password bytes. So once we have the password byte and we have the password solved, then we can generate the password hash. How? By calling this compute hash method, pass this byte array. So once you call, this will generate the password hash. And while it is generating the password hash, internally it is going to make use of this key attribute. Clear?
Yes.
Right? That is for generating the create password. Anyone having any question?
Exactly, I did not get get what's the use of the password salt here. We access it by using the HMAC.key. Why do we need to access it here?
See, without using password salt, right? See, for example, if you want to do some kind of a operation, so for doing that operation, for example, whatever, right? I mean, for example, if you are having one method, if that method taking two parameter, so from your C# code, can you call that method without passing any value? Can you call that method
No.
without passing any value?
No.
No. Similarly, so the hashing algorithm, right? The hashing algorithm, what is being used by the right this right the logic, right? So this HMAX algorithm, what we are using, this is a standard. Standard means what? It is not specific to .NET. This hashing algorithm, what we are using in .NET, it is also available in Java. It is also available in Python. It is also available in C, C++, and whatever technology you take into consideration, all the technologies having this HMAC algorithm. And this is a standard. So the standard of HMAC algorithm is that if you want to generate some kind of a hash code, all right, I mean hash, then for that purpose, what you need to do, you need a key. So based on the key, it is going to generate the password. So what is the use of a password salt? Let me explain you. See, for example, if you are not using this password salt, right? So you send your password, I send my password. You set the password value as a text at the rate 1234. I also send the password as a text at the rate 1234. Without this password salt, whatever the hash is going to be generated, definitely it is going to be same in the case of you as well as in the case of mine. Yes or no? Because the same password, no password salt means what? That generated password hash is going to be same. Yes or no?
Yes.
Yes. But now, but now we are introducing this password salt, which is going to generate a unique key each time you generate this instance of this HMAC algorithm. Now, for example, so in your case, it generates a salt, and in my case, it generates a different salt. As the salt is going to be different, then what will happen? Now, for a single change, right, when the salt is going to be different, then what will happen? Now, in that case, even though the password string, right, the original password or the plain text, what we are sending, it is going to generate a different hash. That means with this salt, now whatever password, right, whatever the string password you send, that is text at the rate 1234, is going to generate a different hash than me. For me, the plain text is going to be same. In your case, that is text at the rate 1234. In my case, it is going to be text at the rate 1234. But because of this password salt, which is going to be different in your case and which is also going to be different in my case, password hash that what it is going to generate is going to be different one. Clear what is the use of this password salt? So basically, for the same password to generate a different hash, we are using password salt. Now you might have one question, sir, what is the benefit? See, benefit is that, for example, in the database, nowadays what happened? Now most of the people, they are storing same kind of a similar password. Test at the rate 1234, admin at the rate 123, and 12345 6, something like this. If you have access to the database and you can group and how many similar password are there, then you can identify. But with this password salt, what will happen? Now each password is going to be, I mean, each password hash is going to be different. So you will not find any two password hash, they are going to be similar. Clear?
Yes.
Okay. So this is how you need to generate the password. Now what we need to do, we need to understand the verify password. So when you want to verify the password, at that time you need three things. One, see, in this case, once you generate this, so from this method, you are returning two information. What are the information? The generated password hash and the generated password salt. And these two information will be stored in the database, password hash and password salt. Now, at the time of login, the user provided the email and the plain text password. So based on the email, can I retrieve the password hash and password salt from the database? Yes, definitely. Why? Because email is going to be unique. Based on the unique email ID, what is the associated password hash and password salt? I will retrieve. And then what I need to do, I need to call this verify password method by passing the plain password, the stored hash, and the stored salt. Now, so in previous case, I created the SMAC algorithm without the password salt. That is the reason why the salt is going to be generated by this SMAC. Now we are already having the password salt. So what we need to do, we need to pass that salt to the SMAC algorithm. Now this time it is not going to generate a unique salt. Rather than whatever salt we are passing, that it will use internally to generate or to compute the password hash. Clear? Why we are passing here? Why not here? Is that clear? Here we need to generate. That is the reason why we are not passing. But here we already have the salt. That is the reason why we are passing that. Clear?
Yes.
Yes.
Right. So once the passwords, once you have created the instance, then what we need to do, you need to convert this password into byte array. So once you have the password, SMAC algorithm, and once we have the password hash, then you can generate the hash here. So I mean, you can compute the hash. So to this hash, we need to pass this password array, and it will generate a computed hash one. So whatever the computed hash and whatever the hash stored in the database, these two we need to compare, right? If both are equal, that means the hash is matched. Otherwise, if both are equal, it will return true. Otherwise, it will return false. Clear?
Yes.
Right. Okay. Now let us try to understand the user controller, right? So basically what I'm going to show you how we can make use of this in our application. So for this purpose, I'm going to create a simple controller. Go ahead. So this is my controller. You can see Uh, I'm taking the user DP context. This is my registered method. First, I'm validating whether the model is valid. I'm checking if the email is already taken by someone else. If already is taken by someone else, we need to return bad request. Then what I'm doing here, I'm calling the password hash method using the password hash or helper class. So this is a class, static method. So I can use the class name and method name, passing the password, which I'm getting from the model, and then I'm passing to output variable to store the password hash and password salt. Then once this method is called, then we need to create the user entity. So here you can see for creating the user entity, first name, last name, email, and the generated password hash and password salt I'm storing. Finally, I'm adding that entity into the user's DB set property calling the set changes method. So this is my login method. So again, I'm validating whether the model state is valid. Then I'm checking whether this email is already, this email is existing in the database or not. If it exists, then retrieve the user detail. If not, then invalid email. If it exists, then what we need to do, I need to call this verify password method. Whatever the user provided password from the model, and the user stored pass has as well as the stored salt, that what I need to pass. So this method is going to return me true or false. If it returns true, I'm using not operator, so it will return this okay message that user logged in successfully. If it returns false, and this not operator will mark this as true, so invalid. So once the login is successful, then you can generate the JWT token, and that is what we are going to discuss in our coming session, right? How to generate the JWT token. So with these changes, now if you run the application, then it will see, right? Then it will work as expected. It will not store the data. So the project is configured to use to avoid SSL. Yes. Now let me run the application. See, this is my register button, right? So what I'm going to do is I'm going to test this one. So first name Pranaya Rout, so password test @123 per, click on the execute button, and this should create one user. See, user registered successfully. Now, if you verify the database, then you will see Pranaya Rout, pranaya@example.com, and this is password hash and the password solved. So this is working as expected. Now we have stored this email ID and password, and now we need to verify whether this functionality, login functionality, is working as expected or not. So let me go ahead. So Pranay Rout and check this one. Yes, user logged in successfully. So this is how you need to store the password in the database. We have already discussed the difference between these two and when to use which are. Clear, guys?
Pranay, can you please register one more